Hey there guys, Paul here from the engineeringmindset.com. In this video we're going to be looking at how to measure the water flow rate through a chiller. Now this is useful to analyze the performance of a chiller and ensure it is meeting the design specifications. In our previous video we looked at how to calculate the cooling capacity of a chiller, and for this you would need to know the flow rate of water through the chiller. There's a link on the screen now if you want to see that, or see the video description below. So to measure the flow rate we need to locate an orifice plate in the system. These will look something like this, although the flange face won't be visible when connected to the pipe, but you can spot these because they have the two pipes sticking out of them. On the engineering schematic drawing you should see them look something like this symbol here. Of course, do check the drawing legend to make sure. We also need a tool to measure the flow rate with, so for this we need a special manometer which can suit the pressure difference of the system. You can buy compact digital versions which are easier to transport and more precise. However, I'm going to use an older mercury based polymeter to measure the flow rate simply because that's all I had available at the time. Now if you're going to buy a manometer, then I recommend spending that little extra to get the digital version. I'll leave some links below as well. So this is a simplified version of the actual chilled and condenser water schematic of the building. As you can see, it has 3 chillers and 3 cooling towers, and this feeds the AHUs in both the east and the west side of the building. Now I've only animated the flow path of the chilled water for this example as that's what we're measuring, although the procedure will be the same if you wanted to measure the condensed water. Just to note that not all 3 chillers do need to run, this would only occur at maximum demand. You can see on the left that the east and the west wing split off from a main header, and the return water joins into another header before returning back to the chillers. This separates the primary and the secondary circuits. Now we've already covered this in another video and the link is on screen now for that if you need to learn that as well. Now also notice that only one of the 2 pumps is running in each pump set. This is because they are using duty and standby configuration where a pump is made the leader and will run while the other pump acts as a backup just in case the leader pump fails. Now these roles are reversed every so often just to keep the run hours similar, and this will usually reverse every week or so. So let's look at a real world example. First we need to find a point in the system that we want to know what the flow rate is. For this we will use this orifice plate here on the chilled water flow pipe coming out of the chiller. We can just check on the drawing legend that this is an orifice plate, which means that we can measure here. So we need to find the evaporator for chiller number 3, which is this one here. Then we follow the pipework until we find the orifice plate, which was just after the bypass valve, and there it is. Now these are likely covered with insulation, so they might be a little difficult to find at first, but you can identify them by spotting the 2 thin tubes which stick out of them. Now the tubes will be coloured, so one tube will be blue, which means this is the low pressure side, and the other tube will be red, which means this is the high pressure side. It will probably have these little plastic tags on them as well to help identify them. Then open up the manometer and find your high pressure side, which is coloured red. Ensure that the 2 top valves to your high and low pressure side are both fully closed, and that the lower middle bypass valve is fully open. Then connect the red high pressure hose to the high pressure tube of the orifice plate. You might need to change the connection fitting depending on which valve has been used. You'll also need to check that the threads are all clean, as these are often covered with dust and dirt. Just turn it hand tight and ensure that it isn't leaking. Lastly, just double check that you've connected the correct hose to the correct side. You should also now check for any pockets of air within the hose or the manometer tubing and flush this out before continuing, as any air pockets will cause inaccuracies with your measurements. Then locate the blue low pressure hose and connect this to the blue low pressure side of the orifice plate. Now you'll need to zero the measurement gauge, so just open up the valve on the high pressure side of the orifice plate as well as the high pressure valve in the manometer, and after that you can then check that the bottom of the little ball within the manometer is level with the 0 mark on the gauge. If it's not level with this, then you can just move the measurement gauge up or down to align this. Now once you're happy with the 0 alignment, you can then open up the low pressure side of the orifice plate. Sometimes when you open these valves up, they dribble just a little bit. If this happens, then just make the connection a little bit tighter and it will stop. After that, you can then open up the low pressure valve within the manometer. And once that's fully open, you can then begin to close the bypass valve. When you do this, make sure you close the bypass valve very slowly and watch the little red ball begin to rise, as this can suddenly shoot up very fast. If it does get too high towards the top, then you should immediately open up the bypass valve fully to prevent the mercury from escaping. So just leave it a moment to settle down, and once it is stable, you can then take a measurement. Now just note that the little ball will likely move up and down slightly, and that's just due to the pumps and the turbulent flow within the pipework. Once you're happy that it has settled down, you can then take the reading. Here you can see it has a reading of around 6.2 kilopascals, and that's just the pressure difference between the high and the low side of the orifice plate. So just take a note of the reading and then you can begin to disconnect the equipment. So to do this, just open up the bypass valve and close the high and low pressure valves within the manometer. After that, you can then close the high pressure valve on the orifice meter and disconnect the hose. Then after that, do exactly the same on the low pressure side of the orifice plate. So now we can calculate the flow rate. To do this, we first need to know what the KVS value is, and this is set by the manufacturer of the orifice plate. Now the KVS value will vary between manufacturers as well as the model numbers and also the size of the orifice plate, so make sure you use the correct value. They will also usually provide a chart too, so you can just perform a very quick lookup. So let's just mark our reading on the chart, which was 6.2 kilopascals, and we'll just put this on the y-axis. Then we can draw a horizontal line across until it hits that dark KVS line. From there we can then draw another line down vertically from there straight down to see what the flow rate is. So here you can see it has a flow rate of around 55 litres per second. But if you want a more precise way, then we can perform a calculation. For that, we need to use this formula, which is the flow rate Q is equal to the KVS value multiplied by the square root of the pressure difference divided by 36. Now we know what our KVS value is, so we can just drop that number in. We also know what the pressure difference value is too, so we can drop that in also. Then we just square that value and multiply it by the KVS value. Then we just divide this all by 36 to get the answer of 54.7 litres per second. And there you have it. That is the water flow rate through your chiller. Okay, that's it for this video. Thank you very much for watching. I hope this has helped. If it has, then please hit the like, subscribe and share button. And if you have any questions, leave them in the comments section below. Don't forget to check out our website, theengineeringmindset.com. We're also available on Facebook, Twitter and Instagram. Thanks again for watching.